Welcome to this video, which is a graphical approach of concavity. So here we're going to use the graph of y equals f of x to identify the local extrema of f of x, the intervals on which the graph of f is concave upward, the intervals on which the graph of f is concave downward, and we're going to determine the inflection points. So let's start with the extrema, the local extrema of f. First question. Here we can see clearly that we have a local extrema at this point and a local minimum at this point. So we're going to say that we have a local maximum at x equals -2. It corresponds to x equals -2. A local minimum at x equals 2. And that's it. Okay? Second, intervals on which the graph of f is concave upward. We can see clearly that the concavity of this function changes around this point, which is x equals 0. We have a concave upward for this side, and here it's concave downward. So the graph will open downward for this left side and opens upward on this right side. So we're going to say that the intervals, so f is concave upward on 0, infinity. So starting from x equals 0 to infinity. Now third question, f is concave downward on negative infinity 0 on the left side. Okay, now what are the inflection points of this function? Remember that inflection points are points in the domain where f second of x changes sign, or the concavity changes. Okay, we can see clearly here that at this point, which belongs to the domain of the function, the concavity changes from downward to upward. So this is an inflection point. So we have an inflection point at x equals 0. So we're going to use 0. And what is the output here? The output is 1. Okay, so let's say that the point 0, 1. So the point 0, 1 is an inflection point. Or you may say there is an inflection point for x equals 0, or at x equals 0, okay? An inflection point. So that's it. We are done for this activity. See you in the next videos.